In 8.7, we are going to start throwing in the rest of the problems that you had in 8.4 and 8.5, except the only difference is now you're going to have to use radians. You should be able to do sine, cosine, tangent, secant, cosecant, cotangent for any angle in degrees and in radians, positive angles or negative angles, doesn't matter. You're going to be able to figure out what the ratios are, things that are on the unit circle, and so on. Everything's the same, and I just need to say this for the record. Your test is without the use of a calculator. Your test is without the use of a unit circle. And as we said before during the warm-up or during homework checking, you can draw your own unit circle when you get to the test. You just have to make sure it doesn't take you the whole amount of time. If it's taking you longer than 3 minutes to draw a unit circle, I would not recommend it. I would just recommend memorizing it or memorize the hand trick. There's only two concepts that we have not talked about that are in this section. The first is if I ask you to find a point. If I ask you to find a point that corresponds with an angle, you're going to tell me the x, comma, y, the cosine, comma, sine of whichever angle I am talking about. If I said for number 19, give the point on the unit circle that corresponds to the given angle, and we're talking about 3 pi over 4, you need to think, okay, where's 3 pi over 4? I'm doing this without a unit circle. I'm doing it from my head. I go 3 pi over 4, this is just me thinking, is right about there. 1 pi over 4, 2 pi over 4, 3 pi over 4 is quadrant 2. I know what the reference angle is, pi over 4. I know what the coordinates are. Negative for cosine, positive for sine. This is my answer. If I ask for the point, I'm asking for the x, comma, y of that angle. Notice I did not do any work other than, okay, that's quadrant 2, the cosine's negative, the sine is positive, my x is negative, my sine is positive. I fold down this finger if I use the hand trick, and I know it's root 2 over 2, root 2 over 2, square root fingers over 2. That's the first concept that we haven't talked about. The second concept is sometimes you're going to have to convert from degrees to radians or from radians to degrees. It just depends what you want to get rid of. If you want to get rid of radians, then you better make sure radians are on bottom. If you want to go from radians to or degrees to radians, then you got to get rid of degrees. Put degrees on bottom. Depending what you want to figure out, that will depend on what you put on bottom of your conversion factor that you're multiplying by. So we'll do some of those. That brings me to this picture. It's one of my favorite trig pictures of all time. It shows this guy in class, and he's making his move. If you don't know what that means, he's trying to impress a young lady. He says, "Hey girl." In that voice, "Hey girl, what's your sign?" And then he says, "It must be pi over 2. If you don't know and you go to pi over 2 on your unit circle, look at what the sign is of pi over 2. Straight up and down, the sign is the 1. What's your sign? It must be pi over 2 because you're the 1. And then the best part is the friend's face. She's like, "Oh my gosh, how embarrassing." I like it. Attaboy. Way to go. Some of you might actually find yourself having to talk to a neighbor one day. It'll be great. Hey. I don't know. I just like it. Here we go. Let's do some problems. The secant of pi over 3. You should be able to figure it out. If you need to review what we've covered in class or what we covered in section 6 was 0 radians, pi over 6 radians, pi over 4 radians, pi over 3 radians, pi over 2. Those are our reference angles. This is pi over 3. I want to find, well, I should say, the first thing I do is I check the sign. Quadrant 1. Cosine and its cousin secant are positive in quadrant 1. I kind of sort of do this and I think about that. I go, okay, it's positive in quadrant 1. Then I think I need to know what the cosine is of pi over 3. The cosine is 1 over 2. But I need the reciprocal. You could write 2 over 1, but in my mind, I think you should know how to simplify 2 divided by 1. I think you should be able to write 2 and not 2 divided by 1. Somebody asked me in my other class, would you mark us wrong if we put 2 over 1? I would be like, I guess it just depends on my mood. If I was in a really good mood and I was like, yeah, all right, let's go. You know what I mean? I might say, that doesn't matter. But then there's times where I go, no, we should simplify that, if I'm really being picky. So let me just warn you and say, if you want to even risk it, 2 divided by 1 is 2. Write down 2. It's more simplified. Warning. I am in a pretty good mood most of the time. But you never know if, I'm grading these at home and then I have somebody playing the piano. If that happens, sometimes I start like that. Okay. Number 4. Cotangent of pi over 6. I think you guys can do this. So it doesn't matter that I'm recording a video or not. I want you to try 4 and try 17. North person, you are going to get number 4. South person, you're going to get number 17. You are then going to check with each other to see if you both got the same answer. I will reveal the correct answer in 2 minutes. Go.
I got radical 3.
Yep.
You want to do 17, huh? What'd you get? I got 0. I think everyone should like and subscribe to the video on YouTube. Big brain. Alright.
Show of hands. Show of hands. How many of you got both number 4 and number 17 correct? You got root 3 and you got 0. Raise your hand, please. You got both correct. Okay. How many got only 1 correct? Raise your hand. How many of you got both of them wrong? Raise your hand. Okay. Now that I've seen how many that is, let's just go through how I did it. Cotangent of pi over 6. The first thing I do is hold my hand. 0, pi over 6, pi over 4, pi over 3, pi over 2. I fold down pi over 6. Cotangent is the reciprocal to sine divided by cosine, or the reciprocal to tangent. So what I do is I say cotangent is cosine divided by sine. The left side divided by the right side. Root 3 divided by 1. Technically it's this, but those denominators cancel, and so I literally just think about this number on top and over this number on bottom. Thank you. Which simplifies to root 3. 5 pi, on the other hand, if you think about what we talked about, this is 1 pi, this is 2 pi, go around again, 3 pi, 4 pi, 5 pi is in the same spot as pi. 5 pi is coterminal with pi, which means if I know what the ordered pair is at pi, I know what the ordered pair is for 5 pi. Sine, sire is the y value. The y value is 0. The answer should be 0. The last example that I have for you is number 26. Negative 330 degrees. We're going to convert it from degrees to radians. If we're trying to get rid of degrees, then the conversion factor better have degrees on bottom. I know that 180 degrees is the same thing as pi radians. Degrees and degrees will basically cancel each other out. You'll be left with how many radians there are. So, I just reduce these. I divide by 10. I get negative 33. I divide by 10. I get 18. I divide by 3. I get negative 11. I divide by 3. I get 6. I'm just reducing these in my head because Mr. Paramo said there's no calculator allowed. I have to be able to do this by hand without a calculator. I'm showing you how you take big numbers and just look for it. Let me divide it once, maybe twice. And then top times the top. Bottom is all by itself. That doesn't reduce. It's in lowest terms. The negative angle stays a negative angle. Negative 330 is the same thing as negative 11 pi over 6. That's all you got to do. And that's where I'm going to end your notes. If this video is helpful for you, don't forget to hit like or subscribe.